Hello class, welcome to your notes for October 1st. So today we're going to be talking about representing, naming, and evaluating functions. So we're going to start with the example where we have a function, f of x equals 3x plus 5. And we want to determine the output of this function when x equals 8. So another way of saying this is we want to find f of 8. To do this, all we have to do is replace all of the x's with the number 8. So f of 8 is equal to 3 times 8, because x is 8, plus 5, which equals to 24 plus 5, which is 29. So f of 8 equals 29. If we were to find a different value, let's say f of 4, we would follow the same rule. Replace all x's with the number 4. So we have 3 times 4, which is our x, plus 5. 3 times 4 is 12, and we add 5 to get to 17. So here's a question for you. What is the value of f of negative 2? All right. So f of negative 2, we're just going to replace all of our x's with negative 2. So f of negative 2 is equal to 3 times negative 2 plus 5. 3 times negative 2 is negative 6. Add 5. And f of negative 2 then becomes equal to negative 1. And that is our final answer for f of negative 2. So let's remember from yesterday that the domain is all of the possible values for x in a function, and the range is all of the possible values for y. So domain is x and range is y. This will be important for our next question. So here it is. A ball is thrown into the air with an initial velocity or speed of 15 meters per second. The function f of t equals negative 4.9 t squared plus 15t plus 3 represents the height of the ball above the ground in meters as a function of time t. So t here is our variable time, and over time this f of t tells us how high the ball is above the ground. So determine h of 2, this should say f of 2, and explain what it means. So we're going to do the same thing that we just did before. We're going to place all of our t's with 2. So we'll have f of 2, which equals negative 4.9 multiplied by 2 squared plus 15 multiplied by 2 plus 3. Now, you might need a calculator for this one. Negative 4.9 times 2 squared is equal to negative 19.6. 15 times 2 is 30, and we'll keep the 3. And then when we add all of that together, we get 13.4. So f of 2 is equal to 13.4. Now what does this mean? So our t, our 2, is how much time it's taken, and that's in seconds. And our f of 2, that describes our height. So what this means is that after 2 seconds, the ball is 13.4 meters above the ground. So yeah, after 2 seconds, the ball is going to be above the ground by 13.4 meters. All right. The next question that we have here is -3 a reasonable input for t in this function? So I'll give you a minute to think about that. Do you think that -3 is something that we could put in for t? Which is the time? And why do you think that? All right. So for me, -3 is not reasonable. And the reason is we don't do negative time. So negative time doesn't make sense. All right, so that has to do with the domain. So we know that negative numbers aren't going to be in our domain because we wouldn't input negative times. So now we have a graph. So this graph represents the height of the ball with respect to time. So this graph is actually the same as our equation or our function f of t equals -4.9 t squared plus, what was it, 15t plus 3. So that's what this graph is right here. So we've got time and height. So this graph and this function represent the same thing. So now I want to know what a reasonable domain is. Remember, domain is possible inputs. So inputs would be our t, our time. Let's look at the graph and see all of the possible times we have. So we start at 0, and it goes, and it lands here. That's between 3 seconds and 3.5 seconds. So I think a reasonable domain on this one would be something starting at 0, including 0, and then t. So t is between 0 and, let's say, 3.25, which is somewhere between the 3 and the 3.5 that we have. So these are our possible inputs. We can put anything from 0 to 3.25, and we'll get an answer. Now the range, these are our outputs. So the outputs is the height. So that starts at about 3, then it goes up and up and up and up, and it's somewhere, looks like between 14 and 15. And then it goes all the way back down and hits the ground, so it's 0 feet above the ground. So you start with the lowest, so the lowest it gets is 0. It never goes underground. And then we've got f of t here. And the highest it got, we'll say, was like 15 or so. So on this one, it looks like it was probably a little bit less than 15, but we can call it 15, and that'll be okay. So the range is all of the outputs that you can possibly see. So that's the heights, and the domain is all the inputs, all of the times that make sense in the problem. All right. One more example here. We have this, that medical professionals say that 98.6 degrees Fahrenheit is the normal body temperature of an average person. Healthy individuals' temperatures should not vary more than 0.5 degrees Fahrenheit from that temperature. So we need an absolute value function, f of t, to describe an individual's difference from normal body temperature, where t is the current body temperature. So we always start with f of t equals, and absolute value, if you remember, looks like this with the 2 lines. And we want to know the difference from normal, which is 98.6 degrees. So we'll take our temperature and subtract 98.6. So our difference is t minus 98.6. Difference always means subtract. So this is our function right here. And now we can use this function to determine what f of 101.5 would be. So we'll do f of 101.5, and we'll plug in 101.5 for all of the t's. In our function, there's only one. It's 101.5 minus 98.6, and that equals the absolute value of 2.9. And the absolute value, if you remember, just makes everything positive. This is already positive, so it just equals 2.9. So f of 101.5 is equal to 2.9. What does this tell you about the individual? You probably already know this, but if you have a temperature of 101.5, they're sick. And this is because their temperature is more than the 0.5 degrees from the normal temperature. It's 2.9, which is greater than 0.5. So a reasonable domain for a healthy individual. So we need to find all of the temperatures that are within 0.5 degrees of 98.6. So we can do 98.6 and add a half, or we can do 98.6 and subtract a half, and all of that would be within the healthy range. This is 99.1, and this is 98.1. So the reasonable domain would be between 98.1 and 99.1. All right. That's the end of today's notes. You'll have a worksheet to do. This worksheet is going to be available on tinyurl.com/MarechalNotes2019. So if you would, go ahead and pull that up and start working. It will be due Thursday first thing when I come back.